Sakina, am I audible?
Yes, you are.
Sorry, I couldn't hear you. Please, can you repeat?
I am in India and I am in UAE.
Okay, okay. And what have you completed in 12th math syllabus?
We completed every portion, got over.
Okay, so you are preparing for some competitive exam or just for CBSE?
Now, currently, I'm preparing for CBSE.
Okay, cool. So you have prepared all. I mean, you have covered all the basic topics, right?
Yes.
Okay. So actually, I would like to tell you what we are going through. So we have been completing integration, and we have completed most of the part.
Okay.
So it is divided into two parts. One is indefinite integral, which we have already covered. And right now we are on definite integral. So basically covered definite integral almost all the parts. Plus today we will be going to discuss about the properties of definite integration. So today almost we will be able to complete integration part, and then we'll move forward to that area between curves and differential equations. Right. So I think this is the most difficult part which you guys face in class 12 math syllabus, integration. Basically, this is a whole unit integral calculus, which includes 3 chapters. So you'll be, I think you'll be getting around 12 or 13 marks from this chapter only, integration, in your board exams. So these classes are strictly for CBSE only, right?
Yes.
Okay, then let's start with your doubts first. Fatima or Sana, if you have any doubt, please feel free to ask. From exercise 7.9 or 7.10. Okay, in that case, we'll, sorry. Okay, cool. So in that case, we should start with the properties of definite integration. So we have already covered what is the basic definition of definite integral. How is this integration different from indefinite part, right? And how to basically how to apply substitution in definite integration, right? We have discussed this part. So we know what basic integration is. So let's say if we have function fx, let me revise you. Let me just give you the basic concept. So if we have a function fx and we want to integrate it, then we'll get another function. For this, we need to either may apply by parts or partial fraction or substitution. We had 3 basic methods to solve indefinite integration, right? And when we were doing indefinite integration, so we have always used this C, which basically represents constant of integration. We have talked about it in detail, that why is this happening, right? Now, if we come to definite integration, the only change is it has limits. And within limits, if we solve any integration, then we are basically getting an area under this curve fx. Right? So let's say we have this graph of function fx, and suppose we want to integrate it from a to b. This is x is equals to a, and this is some x is equals to b, and we are integrating fx over a to b. So basically what we are getting is, if you want to solve this, if you want to interpret what is this expression, this expression is basically the area of this part, the shaded part, right? The area under this curve fx. Now area under this curve, if you see, the area under this curve is infinite, right? But we have to only consider the area till axis, x-axis or y-axis. Can be anyone. But in this case, because we are integrating fx, the function of x, so we will be seeing this x-axis. So up to x-axis, whatever the area is under this curve fx, that is basically this expression. Area under curve fx from a to b. The limits can be anything. And if you consider basically this is x is equals to 1 to x is equals to 5. So you're trying to find out the area under this curve fx from limit 1 up to limit 5. You can change that 1 to 3. So in that case, the area will reduce, right? So this is basically the physical interpretation of the expression which we are solving, which we are trying to solve, fx a to b dx, right? So this will be this, if suppose the integration of fx was gx, now the integration of fx is again gx. But in this case, we will not use c because we don't need c, right? In this case, we will be getting this function gx, which will be then integrated from limit a to limit b. And first we will put upper limit. So this will become gb. We have to put b in place of x in the function, and then minus lower limit. Upper limit minus lower limit would always be the answer. And this is how we solve definite integration, right? This is the basic concept, very basic concept. I also told you, yeah, please, Fatima, you to us. Okay, you're writing. Okay. So this I told you because we will be using this in the next chapter. Area under curves. Area under curves is basically the application of definite integration. Why did we solve? Why did we define definite integration? Why did we need to use it? Because we wanted to find out the area under irregular surfaces. We know what is the area of a rectangle. We know what is the area of a cube, or let's say square or sphere, cone, cylinders. These are regular figures, right? So we know what the area of these figures are. But we don't know if I tell you some shape, let's say there are many shapes. So whenever we use any curve, let's say this is a curve, right? And we want to find out the area under this curve. I mean, area of this curve. So in this case, this is not your some regular shape. So you don't know how to calculate the area of these surfaces. So whenever any irregular surface comes, what we do is we integrate them over the limits. I mean, we try to find out the dimensions under which we need to integrate, and we integrate them to find out the area. That is why we are using definite integration. And that will be the exact use of this definite integration in the next chapter. So the basic physical interpretation is this, that we are trying to find out the area under any curve. Now, we have already seen these kind of examples, like how to integrate x square within the limit of 1 to 4. So nothing else. X square, the integration of x square is x cubed by 3. We need to integrate it from 1 to 4. The thing we have already talked about is we have to put the upper limit first. So it will be 4 cubed by 3 minus lower limit 1 cubed by 3. That would be the answer. In this case, the answer should be 63 by 3. It should be 21. Now, as we have not given any units here, so we are not using any units. But if I would have said you, so let's see what does this represent? This we can see in a better way actually, because we know the graph of x square. Here we were talking about any general function fx. Fx could have been anything. Now we know what fx is. In this case, fx is x square. The graph of x square is something like this. This is not the exact graph though, not scale, but similarly like this, right? This is the graph of x square, y is equals to x square. By the way, this figure is known as parabola, if you don't know. This is parabola, y is equals to x square. So what we are trying to find out here is 1 to 4. We're basically finding out this, let's say this point is 1 and this point is some 4. So when we integrated x square from 1 to 4, we got this area. The area under x square from 1 to 4. This area. So this area, if we would have been finding out in the next chapter, we will be doing this, exactly doing this, that we need to find out the area between the area below the curve x square from 1 to 4. So in that case, this 21 would have been 21 centimeter or unit square, whatever unit you take. 21 unit square. But because we are not using the concept of area right now, so we just wrote 21. So in the question, you will be told that you need to find area. In that case, the procedure will be same. To find out the area under any curve, the procedure will be exact same. You just need to apply the units. Now, this is one important part. Like why we are solving definite integration, why we are using definite integration to find out the area under irregular surfaces. Now, some functions are not directly integrable, right? Have you written this, guys? If someone hasn't written, please.
Yes, sir.
Okay. Just raise your hand if you haven't written. Otherwise, I will erase this. So see, some functions are not directly integrable, right? Just a minute, guys. Sorry guys. Sorry for the interruption. So yeah, what were we talking about? Yeah, so I think I was talking about that some functions are non-integrable, right? You cannot integrate these functions. So let's say, for example, uh, these are some of the functions: sine root x divided by root x. If you want to integrate this function, you will not be able to solve it, right? Because there is no function on differentiating which you will get this function sine root x by root x, right? So there are some functions which are not integrable, right? Or if you want to integrate sine of x square, you will not be able to solve it. There is no way you can integrate sine of x square. So there are some functions which are non-integrable, which cannot be integrated, right? But with definite integration, this is possible to integrate some of the functions. So it's a like very good concept, in fact, of definite integration, that with the help of limits, you're able to solve some of the integrations. How? Because there are a lot of properties associated with these limits. Like, this is not just the simple concept. There are properties of definite integration. So basically, with the help of your limits, you'll be able to solve a lot of questions. Also apply these limits to different criteria. Like, so let's discuss first the properties of definite integration. What can we do with the limits? There are many things which can be done. There are many integrals. There are many tough integrals which can be solved easily using limits. So let's solve that part. Let's understand how can limit affect our basic integration. These are some of the properties definite integration. The property one is, so let's say you are solving a function fx, right? Under the limits a to b. Now, if you change your variable, that does not change the integration. Ft dt from a to b. Now, let's understand these properties with the formula. Hadia, we haven't solved much. We have just discussed about the basics, and now we are solving the next part of this definite integration, which is properties, right?
Okay.
Yeah, so we are on the first property only. Let's understand this property, because there is a confusion associated with it, that you have already changed these variables, right? In substitution, you used to change variables, but this is not the substitution. We are not substituting t in place of x. What we are doing is, so let's say you solve x square dx. We have solved this under 1 to 4, right? And the answer was 21. You can solve it easily. But the answer is 21 if you integrate x square from 1 to 4. So what we are saying is, if you just change x with t, we are substituting t, but directly. If the function was x square before, the function is again square function only. We have just changed the notation from x to t. So if we integrate t square with the variable dt from 1 to 4, you will get the same answer. How? Because the process will be same. The function is same. The function is same. As long as the function is same, the answer will be same. That's what we are saying. So if you integrate t square and under the limits 1 to 4, you will get t cubed by 3. From 1 to 4, you'll get 4 cubed by 3 minus 1 cubed by 3. So this is 64 by 3 minus 1 by 3. So this is 63 by 3, which is 21. So as long as the function is same and the limits is same, the answer would be same, right? First property says this. This is a very basic property. You will not be using this like a lot, but yeah, you need to understand this, that as long as the limits and functions are same, the answer will be same. Now the second property is This is also very basic property. Again, understand this. So let's say you are integrating fx, so any function under the limits a to b, right? Now you can interchange these limits. That is, you can change your upper limit to a and your lower limit to b. But if you change this, the answer would be negative of the first part. How? Let's solve this. So understand this with an example. Let's say if we integrate fx, so we get gx as the answer. Right? So if we are integrating fx, we are getting the answer as gx, right? Now, if we apply the limit from a to b, the answer would be gx from a to b. So the answer would be gb minus g. That is how you put the limits, upper limit minus lower limit, right? Now let's take minus common out of this. If I take minus common, it would be ga minus gb. Ga minus gb can be written as gx from a to b gx from a to b, right? Now gx from a to b is same as sorry. So gx from a to b is same as this. Now see what I'm doing is I'm writing ga minus gb as gx from a to b. So if you solve this, you'll get this, right? Now how did you get gx from a to b? If you integrate fx from a to b, sorry, this should be b to a, because the upper limit is a, ga minus gb. So the upper limit should be a, lower limit should be b, right? Now this is nothing but minus of integration fx from b to a. So what I did is basically, if you integrate this function from a to b, the limits would be, sorry. So the first part is this we can actually break into two parts. I have solved both the parts together. Let's understand this first. So this is a very basic thing which we have already discussed, that if let's say if we integrate fx, we are getting gx. We are applying limits from a to b, so this should be gb minus ga. Now this is second part. If I'm integrating from b to a, let's say I change the limits, so the answer should be ga minus gb, nothing but ga minus gb, because the upper limit will be b, upper limit is a in this case. In this case, upper limit is a, lower limit is b. So the answer should be ga minus gb. So if we apply negative behind it, we'll get the same answer as this. So the basic conclusion is, if you interchange the limits, you can easily do that. Just apply a negative before all over the function. So let's say if I want to integrate x squared dx from 4 to 1, so I do not need to solve it again, because I have already found out x square from 1 to 4. So I know what the x square from 4 to 1 is. This is nothing but minus of 21. Right? So that is how we can apply these properties. Now these are two basic properties. I'll tell you which are the properties that we will be using frequently, and we'll be getting a lot of questions on them as well. So if we get a question from definite integration, that will certainly be based on these properties. Just remember this. Properties are the most important section in definite integration. So whatever you will be getting in the exam, that will be based on properties of definite integration. Can I remove this, guys? If somebody hasn't written, just raise your hand. Yes, Sakina, this is the process. I would keep asking you whenever the board is full. I would keep asking you whether you have written it or not. You just need to raise your hand and raise it until you are not done. And
Okay, sir.
yeah. Okay, so these were the two basic properties. Now the third property is, so let's say we are integrating fx from A to B. So then we can always write this fx as, we can divide this limit from A to B into two or more parts. So let's understand this in this way. So if you're integrating x square from 1 to 4, right? We have done this, right? I can also do it from 1 to 2. If I integrate x square from 1 to 2, then 2 to 3, and then 3 to 4, then also I'll be getting the same answer. Now, why is this happening, first of all? So we've already drawn this graph, y is equals to x square, right? We wanted to integrate y square from x square from 1 to 4. So if we integrate x square from 1 to 4, we will basically get this area. We have already talked about it, right? Now, what's the point of breaking the limit? When will we break the limit? That I will tell you a little later. But before that, we can break the limits into as many parts as we want. Like if I want to integrate x square from 1 to 4, I could have integrated it from 1 to 2, 2 to 3, 3 to 4. Obviously, that process would be cumbersome. That process would be long. I would not do that until I need to. But we can certainly do that. And there is a very basic explanation to that. See, 2 and 3, both are the points that comes in between 1 to 4, right? So if you integrate from 1 to 2, you're getting what? Nothing but this area. Now, if you integrate it from 2 to 3, you'll get what? This area. Then if you integrate it from 3 to 4, you'll get this area, right? In total, you'll be getting all the area from 1 to 4. So very basic explanation that we can divide the limits into as many parts as we want. Obviously, we would not do that in every question, but at certain points, we need to do this. Now, that we'll discuss. So we can divide this, we can integrate this fx from A to C and then C to B, or maybe more parts. This is just a basic explanation of that thing only. The only condition is that this C should lie from A to B, in between A to B, right? If we cannot divide this integration, this area of x square from 1 to 4 in between 1 to 5, right? So I cannot write it as 1 to 5 x square dx, right? Plus 5 to 4 x square dx, right? That is not the correct way to write it. Obviously, I can do one thing, although. Just see this. I could have done from 1 to 5, right? From 1 to 5. In that case, I would have already found out this area as well, which I don't need, this part. So first I would have calculated from 1 to 5, and then I would have calculated 4 to 5 and subtracted both of them. So I could have written it in this way as well, that 1 to 5 x squared dx minus 4 to 5 x squared dx. That is for your interpretation. I would not do it because that is stupid. That is a long process, right? I will not do it. But for the interpretation part, for your significant part, I mean, you should realize, you should visualize what is happening here. So for that part, you can understand this, that if you would have calculated x square from 1 to 5, then you must have to subtract the area which you have, extra area which you have calculated, and that extra area is from 4 to 5, right? So you would have done this in this way. That is also correct. Now, the main point is, when do we need to break these limits, right? When would we do that? So the breaking part of the limit is, in particular, it would be used for the modulus function. Whenever you want to find out the integration of modulus function, okay, so used for integration of modulus function. Now, before going further, I would like to listen if you guys know what is modulus function. Can someone explain it to me? What is a modulus function? How does that look? The basic modulus function. Just tell me the basic modulus function, which you have all read about in 11th as well as 12th. Sana, what is modulus function? Do you know any modulus function? Hadia, Sakina, Fatima.
I don't know how to explain that.
Okay, you don't need to explain that. Just tell me the function which you have read. Fx is equals to mod x. You know about mod x, right?
Yes, sir.
Yeah. So this is a modulus function basically. These are two vertical bars. These two vertical bars are known as modulus, right? Until unless we are not applying these bars, that there is no such modulus thing, right? So if we apply these two bars, vertical bars, these are known as modulus. So I will not say vertical bars from later on. I would say modulus, right? So if I apply modulus on x, so this would look like mod x, right? Now, what does that mean? First of all, what does modulus do is, this is the basic modulus function. First basic modulus function, which you should know, right? Now, what is the function of modulus? What does modulus do? Modulus basically tells you the distance. Distance from where? Distance from origin. So this tells me the distance of 4 from origin. Now, because distance is always positive, right? Represents distance. I also want to tell you guys that everything in maths is like, you can visualize everything. These are the topics, these are the functions, these are the basic mathematical principles on which a lot of your daily activities are relying on. You don't know that, but I would like to tell you that a lot of your applications, whatever you are working on, even this app Zoom through which we are connecting right now, that is also must be using somewhere modulus function in its program, right? So all the programming, all the coding is done via mathematical functions only. So a lot of mathematical use, is we are like mathematical. These functions are helping us a lot in writing programs, in writing codes, in technology, and also in like designing automobiles, designing your roads, right? Houses. So a lot of mathematical use, guys. So you can represent, I mean, you can you can see the physical significance of every function of every chapter you're going through. So this modulus basically represents distance. That is why it is always positive. The answer of any modulus would be positive, right? So if you take mod 4, the answer would be 4. I already told you what does that mean. This means that you are trying to calculate the distance of this point 4 from origin. Now you know how to calculate the distance of 4 from origin. This is a basic number line, right? Minus infinity to plus infinity. Now there is some point 0, somewhere 0, somewhere 4. You want to find out the distance of, if you're writing mod 4, that means you want to find out this distance. Now, if you're writing minus of mod of minus 4, what does that mean? That means you're trying to find out the distance of minus 4 and 0. Now, the distance of minus 4 and 0 is also 4 unit. The distance doesn't change. You can say the direction changed, but direction has no impact on distance, right? You can take any direction, the distance would be same if they are at same distance. So the distance of minus 4 from 0 as well as 4 from 0, both are 4 units. So modulus of minus 4 is also 4. That is like, how do we interpret modulus? What is the meaning of modulus? Modulus is basically giving us distance. So it has to be positive, first of all. And how is it positive? That we have just understood, right? Now let's try it mathematically. How is this happening? So mathematically is very simple. If there is a positive number inside modulus, the answer would be positive. If there is a negative number inside modulus, the answer would be the positive part of it, right? So if I write minus 50, the answer would be 50. As simple as that, right? If you write minus of 21, the answer would be 21. But if you write minus of mod 11, what should be the answer? Can anyone tell me?
Minus 11.
Minus 11, right? Because this minus 11, because answer of modulus is 11 only. This minus is applied outside of the modulus, so answer would be minus 11. But the answer of modulus is certainly positive. So if I would have written here minus 11 ka mod, so the modulus of minus 11 would also be 11, but this minus is applying outside, so the answer would be minus 11 only. Right? Okay, now let's understand how is this happening. With this one thing, I mean, geometrically we have understood what is happening here. Geometrically we have already understood that it represents distance. So the geometric intuition is that whenever modulus is applied, we are talking about distance. No, but the mathematical definition is yet to be explained. Can I remove this, guys? If someone is writing, please raise your hand. Okay. No, mathematically, how mod x is giving us positive answer always. Like, how does mod of minus 4 change to 4? What is this explanation? I mean, you told us that it represents distance, but how is this happening mathematically? So mathematically, we actually excluded one step, forgot to write one step. Not we forgot to write, I mean, we would not explain this mathematics every time. There's just one time, just understand how this minus 4 is changing to 4. So what does modulus say is that if the number inside is positive, so let's say if you write mod of 10, then while removing these bars, just remove them directly. So the answer would be 10. But if you write mod of minus 10, what is the mathematical function that is changing it to 10? So whenever you open a negative number inside a modulus, what you do is you put a negative sign behind it. You put a negative sign behind it to make it positive. So the answer now is 10. So simply, if you want to check, how -4 is changing to 4, then again the same logic that whenever a negative number inside the modulus exists, modulus opens up with a negative outside of it. So a negative of -4, and the answer is 4. So the mathematics behind modulus is such that if you put a positive number inside modulus, now the number is positive. This is basically represented by this. So if this x is positive, greater than equal to 0, the answer would be x only. It basically means that if the number inside modulus is positive, the answer would be the number itself. But if the number inside is negative, that is, if this x is less than 0, then you always have to apply minus behind this so that the number is positive. Now apply this rule. Let's apply this here first. First rule is, if the number inside is positive, so the number inside is positive 10, then answer is number itself. So the answer is 10. But if the number inside is negative, let's say this -4, then the answer would be negative of that number. That is 4. So this is how your modulus function is designed. Right? Now the graph of modulus function, you also need to know the graph, because see, I'm not just telling you these things. These are random things for now. These are very random things for now. I mean, these may look to you that these are very random things, but you have to use all of these graphs and all of these concepts in the next chapter. Because if you won't know them, so you would not be able to solve area under curves. So if we see the graph of mod x, so whenever x is positive, now when is x positive? Either in first quadrant or in fourth quadrant, right? And whenever x is negative, the function is different. So we call them these type of functions are known as piecewise function. Piecewise function, because we are describing them, we are defining them in pieces. These functions are not same for all the values of x. They change. They depend on the values of x. So for mod x, this depends whether the x is positive or x is negative. So modulus always depends on the function inside it. So let's say if I write mod of x -1. So before the graph, let me try to explain this as well. So if I want to find out, if I want to open up x -1 common, right? So what should I do? The concept is simple. If the value inside modulus is positive, now the value inside the modulus is x -1. Either this x -1 must be positive or this x -1 must be negative. There are only two possible cases for the value inside a modulus. Either it is positive or it is negative. If this value inside, that is x -1, is positive, the answer would be value itself. If this value inside the modulus is negative, that is, if x -1 is negative, the answer would be negative of the value. Right? Now we can also write this directly as, this is x -1 when x is greater than equal to 1. Just visualize this. If x is greater than equal to 1, this value must be positive. Let's say x is 2. So this would always be positive. So the value inside the modulus is positive whenever x is greater than equal to 1. And whenever x is less than 1, the value must be negative. And whenever the value is negative, the answer would be negative of this number, which would be minus of x -1, which can also be written as 1 minus x. So that is how you can simply change or simply open up any modulus. Right? This modulus is defined for two values, x greater than equal to 1 and x less than 1. This is how you open up a modulus. Now the graph of mod x is, so whenever x is positive, the value is x. x itself, y is equals to x, the graph of y is equals to x is something like this. And whenever x is negative, the value is minus x. Now the graph of y is equals to minus x is something like this. This is the graph for mod x. V-shaped graph. This is V-shaped graph. And this is y is equals to mod x. Contains two branches. This is y is equals to x. And this is y is equals to minus x. So this is how you open a modulus. Now the main application of this third property is for the questions involving modulus. So now let's integrate a function. So let's integrate mod of x minus 1 from 0 to 3. Mod of x minus 1. Let's solve this example. Let's understand what is the application of third part. So third part's application is just for these type of questions. You need to understand this. These are like 7 properties, but you need to understand which property can be used when. So whenever you see the integration of any modulus function, always remember you must use the third property. Now what does third property says? Third property says that you can break your limits from a to b in between a to c and c to b. So basically you can divide this integration from 0 to 3 in as many parts as you want. Now the question is, why do I want to break these limits? Now, why am I breaking this limit is you cannot integrate a modulus function directly. There is no formula defined for modulus function. In fact, if I would have given you this question in indefinite integration, that is without limits, there is no integration, unsolvable. Unsolvable without limits. Right? So there is no formula by which you can solve or by which you can integrate a modulus. So that is why you need to open up this modulus. Now, as soon as you open up this modulus, you see that there are two values of this function. One is for x greater than equal to 1, and the other part is for x less than 1. Our limit contain this point 1. 1 comes in between 0 to 3. So you cannot integrate this function directly from 0 to 3 because there are two values of this function. The function mod of x minus 1, there are two possible values in between these limits. If you would have been integrating this from 1 to 3, this would have been a different, this would be a different question in that case. Because from 1 to 3, the value of this function is same, which is x minus 1. But from 0 to 3, if you talk about from 0 to 3, there are two possible values of this function. It can either be x minus 1 from 1 to 3. And it can be 1 minus x for 0 to 1. So there, because of two possibilities for this function, you need to break this limit. And now how would you break this limit? You know the answer of that. How do you break this limit from 0 to 3 to integrate this?
0 to 1 and 1 to 3.
Yeah, correct. Because there are two possible values of this function. So wherever those values are, I mean, whatever the bisecting point of these two functions is, you have to break the function at that point. So before one, the function is another, I mean, function is different. And after one, the function is different. So that is why you must break this limit from 0 to 1 and 1 to 3 and integrate the subsequent function. So we could have done, guys, can I remove this? If someone hasn't written, please just raise your hand. Okay. Just a minute, guys. Yeah. So if I want to integrate mod of x minus 1, very simple. I would first define my function. So this would be 1 minus x integration from 0 to 1. And then integration of x minus 1 x minus 1 of dx. Now the integration of this would be x minus x square by 2 from 0 to 1 plus this would be x over x square by 2 minus the integration of 1 is x from 1 to 3. So this should be 1 minus 1 by 2. If I put 1 to 1 minus 1 by 2. If I put 0, then I'll get 0. So 1 minus 1 by 2 minus 0. This is the part. This is the answer, the first part. And this would be 9 by 2 minus 3 upper limit minus lower limit. So this would be 1 by 2 minus 1. Right? So this would be minus half and this would be half. Half plus this would be 3 by 2 and this would be minus of minus half. It's become plus half. So this becomes 5 by 2. 2.5. That should be the answer of this point.
Sir,
Yeah, Adya.
sir, isn't it x minus 1?
Which part? Yeah, this is x minus 1, correct?
Is equal to x minus 1, right?
Sorry, where? This part?
Yeah.
First line, second line?
No, first line.
First line, first part, right? 1
Yeah.
minus x. Okay, so this 1 minus x, where does this come from? That is the question, right?
Yes, sir.
Okay, so Hadia, for this part, that is exactly the that is exactly the reason why we are doing this, why we are breaking the limit. Now, to integrate mod of x minus 1, So first of all, we don't have any direct formula. Let's say, if I want to find out the integration of x dx, I know how to do it, right? You know how to do it. How to do it? Just tell me for my confirmation. Do you know how to do this? Integration of x dx.
X square by 2.
Yeah, correct. X square by 2, right? But if I say that integrate mod of x dx, there is no direct formula for this. No formula. Now, why is there no formula? Because you can actually mod x is not differentiable. So if mod x is not differentiable, it is not directly integrable. There's no formula to integrate mod x. Now, how to integrate mod x? To integrate mod x, we first need to define the limits. Only if the limits are defined, we can integrate mod. First rule. Now, the second rule is how will it happen in case of limits? Now, in case of limits, we need to define this function mod x. That we just learned. How did we define? So let's say if I want to define mod of x minus 1. So what does that mean? In fact, to define mod x, what does that mean? Define modulus. Define modulus basically means that we have to remove these bars. We have to remove this modulus. To define a modulus just simply means that remove the modulus. How do we remove the modulus? This is a very, very basic concept to remove the modulus, that if the value inside the modulus is positive, remove them directly. That is, if this value is positive, the answer is value itself. But if this value is negative, apply a negative before it. So that is how we define any modulus. So if I want to define modulus of x minus 1, so if this x minus 1 is positive, that is, if the value inside modulus is positive, the answer would be value itself. Means you can directly remove these bars. But if this value is negative, then the answer would be a negative before the value. The value is x minus 1. Do you understand this?
Yes, sir, I got it.
Yeah. So when will this value be positive? When x is greater than equal to 1. So that is why we broke the function into two parts. Because from 1 to 3, the value of the function is x minus 1. But for 0 to 1, that is basically the values less than 1. The values of x less than 1. So for that part, the function is not defined as x minus 1. The function is defined as minus of x minus 1. So if you understood this, please feel free to ask your doubts first of all. If you're facing doubt in any line, in any concept, please feel free to ask. Do not ever hesitate. But if you understood this, just solve this for me. Mod of 3 minus x dx, and you need to integrate this from 2 to 4. What's the answer? Solve this. Yeah, guys, where did you reach? If you're facing any problem, so you can ask me. I would certainly help you. First, define mod of 3 minus x. First, define mod of 3 minus x. So to define mod of 3 minus x, consider the very basic concept, just how I told you what is modulus function. If the value inside is positive, open it directly. Value inside it, money, in this case is 3 minus x. So if 3 minus x is positive, greater than equal to 0, the answer would be 3 minus x itself. But if 3 minus x is negative, that is less than 0, the answer would be x minus 3. Simply change the sign. You will get two values. There are also tricks to this. I would like you guys to learn these tricks. I will tell you. But before learning the tricks, I would like you guys to understand the concept behind it. Don't just directly learn these tricks. Anji, anyone? Anyone is able to
The
solve
answer.
it or not? Sakina, please tell me the answer.
The answer is 1.
1, yeah, correct. So the value, this modulus can be defined as either 3 minus x or x minus 3. When 3 minus x, when this value is positive. So the value inside it is positive or negative. If positive, the answer is same. If negative, the answer is negative of this part. That is just change the sign. So 3 minus x when? 3 minus x when? 3 minus x is greater than or equal to 0. Now what does that mean? Take that x to right hand side. This would be 3 greater than x. Either you say it 3 greater than x or you say it x less than or equal to 3. Both are same. Both are same. So when x is less than or equal to 3, the answer is this. It obviously means that when x is greater than 3, the answer would be x minus 3. Now 3 comes in between 2 to 4. That is why we have to break the limits. We have to. We don't have any choice. So in this case, this limit should be, we should break this limit from 2 to 3. We should break this limit from 2 to 3 and 3 to 4. So from 2 to 3, the function is 3 minus x. And from 3 to 4, the function is x minus 3. Now you integrate them and find out the answer. I'll leave this here only because the next part is calculation. You can solve that. So this was your third property. Can I remove this now? If you have done this now.
Can you repeat the answer?
What, Hadia? Sorry, I didn't hear you.
Can you say the answer for this question?
Yeah, one. The answer is 1. In the first part, you will get 1 by 2. In the second part, you will also get either, I think, minus half. The answer would be 1. Okay. So this was your third property in which you need to apply you need to break the limits. Now the fourth property, the most important property. Most of the questions will be based on this property. I mean, around 50-60% questions will be based on this property only. So this is, let's say you are integrating fx from a to b. Right? So the integration will be same. The answer would be same if you change your x. If you change your x with a plus b minus x. That is, if you change the function, if you change the variable, sorry, not function, if you change the variable from x to a plus b minus x, right, the answer would be same. So leave your limits as it is. The limits were a to b, the limits still will be a to b, and the function will change to a plus b minus x. This is a very basic substitution, by the way. Not to worry about anything. You can simply prove this. Nobody will ask you the proof, but this is just for your knowledge. If you want to understand it, I mean, see the proof just. So if you want to change, let's say, if I want to prove the why does this change to this? So we can, what I can do is, let's take this function a to b. Now we know we can apply the substitution in any question, right? So if I substitute this x as a plus b minus t. Now what is this a and b? A is lower limit, b is your upper limit, right? A is your lower limit, b is your upper limit, minus t, some variable. So if I substitute x with this value, I also need to substitute dx, and I also need to substitute these limits, right? So in this case, let's find out lower limit. So if x is a, the lower limit will be a plus b minus a, which will be b in this case. So if you put x as a, now you can find out t, the value of t from here. Let's find out the value of t. Take this t into left hand side. So I am substitute x as a plus b minus t. Now to find out t, take t into left hand side and take x into right hand side. So t would be a plus b minus x, right? Now you need to change the lower limit. So lower limit is a. When lower limit is a, that is your x is a. So t would be a plus b minus a, which means that the lower limit for t would be b. Now upper limit. When upper limit is b, your t would be a plus b minus b. That is, your t would be a. So the integration changes to, just understand this. Also, we need to change dx as well, right? So to change dx, just integrate this function with respect to x. So this will become dt by dx, because this t is a variable. A and b were constants, but t is a variable. A and b are constants, so the integration would be 0, minus the integration of x would be 1. So 0 minus 1 is minus 1, right? So hence this dt is minus dx, or this dx is minus dt. You can also say this, right? So this integration changes to, the lower limit becomes b, the upper limit becomes a. In place of x, you can write a plus b minus t, right? In place of t, you can write minus, sorry, in place of dx, you can write minus of dt. Minus of dt. Which is nothing but, if you take this negative into the limits, so you can interchange the limits from a to b. You will also apply one more negative if you change the limits. So one more negative and negative becomes positive only. So a to b, f of a plus b minus t into dt. Now the first property says, if you write this in t or if you write this in x, there is no change. So we can simply write it as f of a plus b minus x dx. Hence, whenever you see any integration and you are not able to spot any property, just always try your luck with this. So to integrate fx from a to b, you can also write it as a to b, just change your variable x with lower limit plus upper limit minus x. Lower limit plus upper limit minus x, minus that variable. We'll see the use of it. We'll see the applications part a little later. Let's first write all the properties. So the same property, fourth, exactly the same property, fourth, right? Can also be seen as, so this is nothing new. I'm not writing anything new, just applying this fourth property into another formula. What is the formula? So let's say this fifth is the limits are given from 0 to a. The limits are given from 0 to a. A is a number, a can be anything, right? The limits are given from 0 to a. So what I can do is I can apply fourth property. Fourth property says that this integration will be equals to the same limit 0 to a, but you can change your x with lower limit plus upper limit minus x. So the variable is x. Right now the variable is x, but we can change this x as lower limit plus upper limit minus the same variable. In that case, this becomes a minus x. So fifth is nothing new, but the application of fourth only. If the limits would have been 0 to a, the function would have changed to f of a minus x. We'll see the use of them. So you can say that this is a particular case of fourth property. Particular case, why we are calling it a particular case? The particular case because the lower limit is fixed as 0. Upper limit can be anything, but the lower limit is always 0. So this is just simply the fourth property only. Nothing new, nothing fancy. Can I remove this? Okay. So the next property, sixth is, these are also important properties. I'm not saying that these are not important, but these will be used a little less than the fourth property. Fourth is the most important one. So, okay. So the next property is, if let's say you write a function, you write an integration of function fx from 0 to 2a. 0 to 2a. So you can also write it as 0 to a, the integration of fx, plus again 0 to a, integration of f of 0 to 2a minus x, that is applying the fourth property only, but with limits 0 to a. Fx, integrate fx also from 0 to a and integrate f of 2a minus x. 2a minus x. You can get that 2a minus x from here if you apply the fourth property. But with the limits 0 to a. That is the only thing. And this also can be changed to seventh property. So seventh and sixth are same. The only difference is, let's say if this f2a minus x is something related to fx. So if this f2a minus, if in sixth, so sorry, I should write it like this. Modification of sixth. This is just the modification of sixth only. So what can happen? There are two cases. If this function f2a minus x gives you fx, let's say this is similar to fx only. There will be a lot of functions which will be like this. Okay. I mean, this will be used as well. You would see a number of questions. So if f of 2a minus x is equals to fx, your same function, in that case, what does this become? This is fx from 0 to a, and this is also fx from 0 to a, right? So your sixth property becomes 0 to 2a fx dx becomes twice of 0 to a fx dx. But if this f of 2a minus x, this function, becomes minus of fx, then your integration becomes 0. And just simply use these substitutions. If you apply them in this case, sixth, if you apply them into sixth, then you'll get these answers. You'll get the answer as 0. So these are particular cases of sixth. Seventh is basically a particular case of sixth. What's the particular case? Particular cases if this function f of 2a minus x becomes either fx or minus fx. Then this integration would be very easy to calculate. If this becomes minus of fx, then the answer is directly 0. And if this becomes plus of fx, that is, it is coming out again fx, then the answer would be twice 0 to a fx dx. I'll explain this in detail when we reach to the question. How to apply this, that you need to understand. Okay, can I remove this now? Cool. Eighth, last property. This is for basically even odd function. First, you need to understand what are even function and what are odd functions. But before that, the property is very simple. Only applied in case of minus a to a limit. Whenever you see the limits as minus a to a. So if the limit is minus 2 to 2, minus 10 to 10, minus 100 to 100, then only these properties are valid. So the eighth property is very easily, I mean, differentiable than others, that the limits would always be minus a to a. In second part also, the limits would be minus a to a. So if you integrate in between limits minus a to a function which is fx, right? The answer would either be 0 to 2a, twice of 0 to a fx dx, or 0. Now, how would we get the answer is 0 or this twice of 0 to 2x? We will get if this function is even, if fx is an even function, so first we need to understand what is an even function. Can someone tell me what is an even function? An even function or odd function? Okay, so the even function is basically when you change your x with minus x, but that doesn't change the function. The function is same. For example, x is square, fx is equals to x square, fx is equals to cos x. So if you change x with minus x, let's understand what is an even and what is an odd function. So if you change here x with minus x, what does the function become? The function is f of minus x is equals to minus of x ka whole square. Minus of x whole square is again x square. So your function is same as before. As you change x with minus x, the function does not change. Or you can also, I mean, if you want to visualize it, if you want to find out the physical significance, just a very simple calculation would do that. That if the answer at 2 and minus 2 is same for that function. So if you put f2, then the answer is 4. But if you calculate f of minus 2, the answer is again 4. So if these are the, I mean, the even functions are the functions which produce the same result at positive and negative values. So if you take 10 and minus 10, the answer would be same. All the functions which do that, all of the functions are called even functions. Now the two very basic even functions are this x square. Square function is an even function because square does not change for positive or negative values, and also cos x. Cos x also does not change for negative and positive values. So whatever answer exists for 60 degree, the answer will be same for minus 60 degree. Cos 100 would be equal to cos of minus 100 degree. And similarly, the odd functions are if you change x with minus x and the function becomes negative of what was it before. Like for example, there are very basic functions, x cube, x, sin x, tan x, all of these are odd functions. Now, how would you calculate? How would you know that it's an odd function or not? Just simply first talk about physical significance. So whatever the answer is at 1, the answer becomes negative as soon as you change your input as minus 1. So let's take fx is equals to x cube. If we talk about x cube, at 2, the answer is 8. If you put x as 2, the answer is 8, right? And if you put x as minus 2, the answer is minus 8. Exact same definition. Whatever the answer is at positive value, the answer becomes negative at negative values. The answer would be same. I mean, the number would be same. Just the negative number. Just the negative part. So, and mathematically, how do you check that? Just change your x with minus x. So if you take minus of x, then you can take any function. I'm just talking about x cube right now. So if I take x cube, this becomes minus of x the whole cube. Minus of x whole cube becomes negative. Negative cube is negative, and x cube is x cube. It becomes minus of x cube. Hence, minus of x cube was fx, right? So whenever your f minus x becomes minus of fx, as soon as you change x with minus x, the function is odd. And when there is no change, there is no effect of negative and positive output on the function is known as even function. So if you want to find out the integration from minus a to a, then but this is only applicable for these limits, minus a to a. So let's say, let's take an example. If I want to find out the integration of sin x dx from minus pi to pi, not from 0 to pi. From 0 to pi, I have to calculate either from other properties or from simple your integration part. But from minus pi to pi, whenever the limits are from minus a to a, I would always check whether the function given is even or odd. So in this case, sine x is an odd function. So the answer would be 0, as sine x is an odd function. But let's say if I want to calculate the integration of minus 2 to 2 x squared dx. Now, as soon as I check the limits are minus 2 to 2, what I would do is I would check whether the inside function is even or odd. Now I know the function is x squared, which is an even function. So the answer would become twice 0 to 2, only the upper limit 2 and the lower limit becomes 0. So 0 to 2 x squared dx. Now we know what's the integration of x squared. Integration of x squared is x cubed by 3 from 0 to 2. So this becomes 8 by 3 into 2, that is 16 by 3. The answer is 16 by 3. You can also check that if you want to calculate. So that is how we can apply these limits. Now in the next class, tomorrow's class will be the last class for integration, definite integration or indefinite integration, the whole integration. And we will apply these properties. We would like to understand the role of these properties in questions. And please take your doubts, come with your doubts if you have any. I will try to take all of them. Okay. Chalo, then let's meet tomorrow. Whenever you are done, you can leave the class now. And for Safa and Maz, guys, just wait for others to come, then we'll start the class. Okay.
Thank you, sir.
Yeah, sure. Sakina, did you understand in the class?
Yes, sir.
Okay. Cool.